Today is August 12th, 2026, and in the next few hours, not next week, not next month, not at some abstract point in the future that feels comfortably distant, the sky above Earth is going to do three things simultaneously that have never happened together in a single calendar day in the entire recorded history of modern astronomy. A 6-planet alignment visible before sunrise, a total solar eclipse crossing Greenland, Iceland, Spain, and Portugal during daylight hours, and the peak of the Perseid meteor shower after dark, under a new moon that guarantees the darkest possible sky for viewing. All three, same day, same rotation of Earth, and the orbital mechanics that produce this specific combination will not align again this way for generations. The title of this script says, "No one alive has ever seen what will happen in our skies." That is not hyperbole. The last time Central and Western Europe experienced a total solar eclipse was August 11th, 1999. Every person who watched the 1999 eclipse from Spain or France or Germany has aged 27 years since that moment. The 2026 eclipse crosses different ground, and people who will stand in its path of totality today are living through the first European total solar eclipse of the 21st century to reach the Iberian Peninsula. For every human being alive who was not yet born in 1999, this is simply the first total solar eclipse of their lives, and it is arriving on the same day as two other major astronomical events that compound its significance into something the calendar has never produced before. Let's build the full scientific picture of all three events, because each one deserves careful explanation before we can understand why their convergence on August 12th, 2026 is genuinely extraordinary. Start with the Perseid meteor shower, because it is the oldest of the three traditions and the one with the deepest roots in human astronomical history. Perseids originate from Comet 109P Swift-Tuttle, which follows a lengthy elliptical orbit around the Sun. As the comet nears the Sun, it sheds fragments of its material, leaving behind a sparse river of rubble in space. Perseids are meteoroids, ranging from tiny sand grains to pebbles, colliding with Earth's atmosphere at an astonishing speed of 40 miles or 60 kilometers per second, creating luminous trails as they vaporize. Comet 109P out of Swift-Tuttle has an orbital period of approximately 130 years. The last time it passed through the inner solar system was 1992. Its next approach is not projected until 2126, but the comet does not need to physically appear for the Perseid shower to occur. What Swift-Tuttle left behind during centuries of previous passages is a diffuse river of cometary debris, dust particles, and small rocky fragments distributed along its orbital path. Earth crosses through that debris stream every year between approximately July 17th and August 24th. As those particles slam into Earth's upper atmosphere at 60 kilometers per second, the friction converts their kinetic energy into light almost instantaneously. A grain of rock the size of a pea produces a streak of light bright enough to see from the ground at 100 kilometers of altitude. That is not an exaggeration. The celestial show occurs high in the atmosphere, well above the regular weather, at altitudes of about 100 kilometers, right at the edge of space. The constellation Perseus, from which the shower appears to radiate, gives the Perseids their name. The radiant is not the source of the meteors. It is a perspective effect, the same optical illusion that makes parallel railroad tracks appear to converge at a vanishing point on the horizon. The meteoroids are actually arriving from all directions in that region of space, but because Earth is moving through the debris stream in a specific direction, the geometry of perspective makes them all appear to streak away from the same point in Perseus. As the night progresses and Perseus rises higher in the northeastern sky, the radiant climbs and the meteor rate increases. This is why the best viewing consistently happens after midnight, when Perseus is well above the horizon and the geometry of the shower is most favorable. Under ideal conditions, viewers can expect from 50 to 100 meteors per hour. The Perseids are known for their swift, vivid streaks that frequently leave behind glowing trails of light and color as they burn through Earth's atmosphere. Adding to the spectacle are fireballs, exceptionally bright meteors that are larger and more dramatic than the typical streak. Fireballs are the Perseids' most celebrated feature. They occur when a meteoroid that is somewhat larger than the typical grain enters the atmosphere and does not completely disintegrate in a fraction of a second. Instead, it persists for longer, producing a sustained bright streak that can last several seconds rather than the instantaneous flash of a typical meteor, and sometimes leaves a visible glowing train in the sky for minutes after the meteor itself has burned away. These glowing trains are not the meteoroid itself continuing to travel. They are the ionized column of atmospheric gas left behind by the passage of the meteoroid, glowing as the excited atoms gradually return to their ground state. On a good Perseid night, a single fireball can be bright enough to cast shadows on the ground. Now, the factor that elevates the 2026 Perseids above every other year's display in recent memory. A new moon on August 12th means dark skies right when we want them. This is not a trivial detail. The moon is the single biggest obstacle to meteor watching for amateur astronomers and casual observers alike. A full moon, or even a half moon, can wash out the fainter meteors completely, reducing the apparent rate from 100 per hour to perhaps 20 or 30 per hour as the brighter background sky masks everything but the most intense events. In years when the Perseid peak falls near a full moon, experienced astronomers plan around the moon's position, watching during the brief window when the moon is below the horizon and the sky is temporarily dark. In years when the peak coincides with a new moon, as it does tonight, there is no such compromise required. The sky is dark from sunset to sunrise. Every meteor down to the faintest threshold of human vision is visible without competition. And the conditions tonight are the best they have been for the Perseids in at least a decade. Now let's step back in time by several hours on the same calendar day and examine what is about to happen to the sun. The moon's dark shadow, or umbra, touches down at sunrise in remote northern Siberia. Soon after, it nearly grazes the North Pole, missing it by 100 km before sweeping south over Greenland's east coast. Totality reaches a maximum of 2 minutes, 18 seconds off Iceland's west coast. The island's capital, Reykjavík, scores 60 seconds of totality starting at 5:48 p.m. local time. Traveling at some 300-400 km/h, the umbra speeds southeast on its way to northern Spain and a tiny corner of Portugal. 3,400 kilometers per hour. That is the speed at which the moon's shadow races across the surface of the Earth during a total solar eclipse. If you were standing at the edge of the path of totality and could somehow see the shadow approaching, it would arrive at roughly 3 times the speed of sound. The darkness comes suddenly. Within totality, it is not just that the sun is blocked. It is that the entire sky transitions from blue daytime to a darkened twilight, in which the brighter stars and planets become visible. The solar corona, the sun's outermost atmosphere, blazes into view as a ghostly white halo, and the temperature drops by several degrees within seconds. Animals respond as if nightfall has arrived. Birds return to roost. Insects cease their activity. And then, typically within 2 minutes, it ends just as abruptly as it began. The scientific significance of this particular eclipse extends well beyond the spectacle of totality itself. Every total solar eclipse is an irreplaceable research opportunity for solar scientists because the solar corona, the outermost layer of the sun's atmosphere, can only be studied in full detail when the sun's overwhelming photospheric brightness is blocked by the moon. During the approximately 2 minutes of totality along the path, chronograph instruments deployed by research teams can gather data on the corona's structure, temperature, and plasma dynamics that cannot be obtained through any other observational method during the rest of the year. The corona's temperature, which paradoxically reaches millions of degrees Kelvin while the solar surface below it is only about 5,178 Kelvin, is one of the longest standing unsolved problems in solar physics. And each eclipse provides another set of observations that constrains the theories attempting to explain it. During and well before totality, Venus at magnitude minus 4.4 will be easy to spot 46 degrees east of the sun, as seen from Reykjavík, Iceland. This visibility of planets during totality is one of the eclipse's most visually striking phenomena. During the daytime hours before the eclipse, Venus is invisible to the naked eye, not because it is absent from the sky, but because the sky's blue light scattering drowns it out. When totality eliminates that background, Venus snaps into view immediately, bright enough to be unmistakably vivid against a twilight sky that has appeared in minutes rather than hours. Observers who know where to look may also spot Mercury, Mars, Jupiter, and other planets during the darkened totality window, depending on their position relative to the sun on the specific date. August 12th will bring several spectacular but completely predictable astronomical events. Not the end of the world. It brings together Europe's first total solar eclipse visible from Central and Western Europe since 1999, a morning planet parade, and a moon-free Perseid peak. The explicit statement about this not being the end of the world is necessary context because viral misinformation circulates predictably around every major eclipse or astronomical convergence. Viral claims that Earth will lose gravity for several seconds have no scientific basis. The eclipse is simply the moon's shadow crossing Earth. It cannot switch off or noticeably change the planet's gravity. A total solar eclipse is among the most completely and precisely predictable events in all of astronomy. The geometry of Earth-Moon-Sun alignment can be calculated with centimeter precision centuries in advance. There is no hidden physics. There is no surprise mechanism. The same gravitational forces that have governed the orbits of these three bodies for 4.5 billion years are the ones producing this eclipse on August 12, 2026. The wonder of it does not require enhancement through misinformation, because the honest science is already extraordinary. Now let's describe the third component of today's triple convergence, the planetary alignment. Before sunrise on August 12th, observers across much of the northern hemisphere will be able to see 6 planets aligned in the pre-dawn sky. The 6 planets visible to various degrees are Mercury, Venus, Mars, Jupiter, Saturn, and Uranus. The innermost 4, Mercury, Venus, Mars, and Jupiter, are bright enough to see with the naked eye without any optical aid. Saturn, while dimmer, is still visible to the naked eye under dark skies. Uranus, at its typical brightness, sits right at the threshold of naked eye visibility under excellent conditions and is easily found with binoculars. To understand what makes a planetary alignment visually striking and scientifically meaningful, you need to understand why all the planets appear near the ecliptic, the imaginary line across the sky that traces the sun's apparent annual path through the constellations. The solar system was formed from a rotating disk of gas and dust, and because all the planets condensed from that same disk, they all orbit the sun in roughly the same plane. When you look at the sky from Earth, you are looking at that orbital plane, edge on. All the planets appear strung along the same narrow strip of sky, the ecliptic, because they are all orbiting in what is nearly the same geometric plane. A planetary alignment is simply a moment when several planets happen to be located in the same general region of the sky along that strip, making their mutual proximity visually obvious. What makes today's alignment notable is both the number of planets simultaneously visible in the pre-dawn sky and the coincidence of timing that places this alignment on the same day as the eclipse and the Perseid peak. Each of these 3 events has its own independent physical cause. The eclipse is caused by the moon's orbit around Earth, bringing it to the precise location in space where its apparent disk exactly covers the sun's apparent disk. The Perseid shower is caused by Earth's orbit around the sun, bringing it through the debris trail left by Comet Swift-Tuttle at the same point in the calendar every year. The planetary alignment is caused by the independent orbital motions of 6 planets reaching a phase where they happen to occupy adjacent sectors of the sky simultaneously. None of these 3 processes is causally connected to the others. They are converging on the same calendar date through sheer geometric coincidence, and that coincidence is genuinely rare. Not every year produces even one of these events on optimal viewing conditions. The 2026 Perseid peak under a new moon is the best in a decade. The European total solar eclipse is the first since 1999 to reach the Iberian Peninsula. And the 6-planet alignment occurring on the same date as both of those events is not something that can be found again in the near-term astronomical calendar through quick searching. Let's now be specific about how to actually observe what is happening today, because the astronomical reality of this convergence deserves to be fully experienced rather than merely intellectually understood. For the planetary alignment before sunrise, the ideal viewing time is approximately 90 minutes before your local sunrise, when the sky has brightened enough to see the horizon, but is still dark enough for the fainter planets to be visible. Face east, southeast. Jupiter will be the brightest point in that direction, unmistakably bright and steady. Venus will appear, similarly, brilliant at a different position along the same arc of sky. Mars can be identified by its distinctly reddish-orange color. Saturn appears yellowish and steady, unlike stars which twinkle. Mercury, close to the horizon in the growing twilight, may require binoculars and a clear, unobstructed eastern horizon to see. The key to identifying planets versus stars in this context is the steadiness of their light. Stars twinkle visibly because their light passes through many more. Kilometers of atmospheric turbulence before reaching your eye. Planets, being tiny disks rather than point sources, average out that turbulence and appear steady. Once you know the difference, it becomes immediately recognizable. For the solar eclipse, the critical requirement is safe viewing equipment for every phase of the eclipse except totality itself. The American Astronomical Society maintains a comprehensive vendor list for safe, approved solar filters for viewing the eclipse's partial phases. Looking directly at the partially eclipsed sun without a certified solar filter can cause permanent retinal damage, because the intensity of solar radiation reaching the eye is not noticeably reduced during partial phases. The human eye does not reliably signal that it is being damaged by solar radiation because the retina has no pain receptors. The damage is invisible until after it has occurred. Certified solar eclipse glasses are inexpensive, widely available, and completely solve this problem. They reduce the sun's apparent brightness to a safe level, while still transmitting enough visible light to see the crescent shape during partial phases. The only moment during a total solar eclipse when it is safe to look without filters is during the brief window of totality itself, when the sun's photosphere is completely blocked by the moon. That window lasts at most 2 minutes and 18 seconds at any given location along the path of totality. A precise verbal warning or timer is essential to know when to remove filters for totality and when to replace them as the moon's limb begins to move away. For those outside the path of totality, the eclipse will appear as a partial eclipse, with the moon covering some fraction of the sun's disk, but not all of it. Even 99% coverage does not produce totality's dramatic darkening of the sky and appearance of the corona. The path of totality is narrow, typically 100 to 200 kilometers wide, and the experience of total versus partial eclipse is qualitatively different in ways that cannot be bridged by remaining just outside the path. This spectacular show is incredibly lucky. Whether you're able to catch just one or both, there's something incredible waiting in the sky for you. That framing is exactly right. An observer in Iceland who experiences totality during the afternoon and then watches Perseids after dark is living through a day that astronomy history will remember. An observer in North America who cannot see the eclipse but steps outside in a dark field after midnight will still witness the best Perseid display in a decade. An observer in East Asia who misses both the eclipse and the primary Perseid viewing window can still see the planet parade before their local sunrise. The triple convergence is a global event experienced differently at every longitude and latitude, but not any single person anywhere on Earth is geographically isolated from all three of its components. Now let's put this triple astronomical convergence in its deeper historical and philosophical context, because the physics alone does not fully capture why August 12th, 2026 deserves the attention it is receiving. Human beings have been watching eclipses for as long as human beings have been organized enough to leave records. The Babylonians maintained systematic records of lunar and solar eclipses as early as the 8th century BCE. The ancient Greeks used eclipse observations to make the first serious estimates of the Earth-Moon distance. Chinese astronomical records of eclipse observations date back to at least the 7th century BCE. Throughout most of human history, total solar eclipses were among the most terrifying events in the natural world, arriving without warning to people who had no predictive model for them, turning day to night in minutes, causing stars to appear where they had no business being, producing a visible halo around the dark disk where the sun had been, and then, most disorienting of all, restoring daylight just as abruptly. The associations with divine anger, the death of kings, the end of eras, all of these cultural responses are completely intelligible as the reaction of intelligent people confronting a phenomenon they had no framework to explain. The ancient Chinese concept of a celestial, dragon eating the sun, the noise-making and drum-beating intended to drive it away, the ritual responses across cultures that preserved communities through the terror, all of it reflects minds trying to make sense of an event that violated every expectation about how the sky behaved. Today's eclipse, by contrast, was computed centuries ago. The precise path of the moon's shadow across Greenland, Iceland, Spain, and Portugal on August 12, 2026 was calculated from the same gravitational laws that Newton formalized in the late 17th century and that have been refined continuously since. NASA and Italian astronomer Gianluca Massi will stream it live for those unable to see the eclipse in person. The experience of watching a total solar eclipse in the 21st century is the same physical phenomenon that produced terror in every civilization that encountered it unprepared, now witnessed with full predictive understanding of its mechanism, its duration, its geometry, and its inevitable conclusion. The corona is still beautiful. The sudden stars are still viscerally startling. The temperature drop is still felt on the skin. The emotional impact of standing in the moon's shadow and looking at a darkened sun with a blazing corona is still profound. But it is profound for different reasons now, for reasons that include the knowledge of what we are seeing and how extraordinarily well the mathematics predicts it. The Perseid meteor shower has its own deep thread in human history. August fireballs were observed and recorded long before anyone knew their origin. The Roman historian Pliny the Elder described the August sky in terms that clearly reference what we now recognize as the Perseid shower. Medieval European traditions described the Perseids as the tears of Saint Lawrence, whose feast day falls on August 10th, close enough to the shower's peak that the association was memorable. The connection of this specific period of the sky to the phenomenon was made empirically through centuries of observation before anyone understood what comets were or that Earth orbited the Sun through a dispersed trail of cometary debris. The discovery of the Perseids' cometary origin came in the 19th century when Giovanni Schiaparelli, best known for his later and controversial observations of what he called canali on Mars, computed the orbit of the Perseid meteoroid stream and recognized that it matched the orbit of comet Swift-Tuttle, which had been independently discovered by American astronomers Horace Tuttle and Lewis Swift in 1862. That connection between a periodic comet's debris trail and an annual meteor shower was one of the most important insights in the history of meteor science, and it established the paradigm that still organizes meteor shower research today. Every major meteor shower now has an identified parent body, either a comet or a near-Earth asteroid, and the annually predictable nature of those showers reflects the long-term stability of those debris streams in the orbits that cometary passages established. The Perseids peak on the night of August 12th into the early hours of August 13th, producing up to 100 shooting stars per hour under ideal night skies. Renowned as the most popular celestial event of the summer, this year's display offers an extraordinary astronomical alignment coinciding directly with the rare August 12th total solar eclipse across Greenland, Iceland, and Spain. Because the peak arrives during the new moon phase, the sky will be completely dark with zero moonlight interference all night long. Zero moonlight interference. That phrase, technically precise and immediately understood by anyone who has tried to watch meteors through a moonlit sky, captures why 2026 is the year that meteor enthusiasts have been anticipating. The new moon occurs on August 12, 2026, the same date as the Perseid peak. The moon will rise and set with the sun, never appearing above the horizon during the night. The sky after astronomical twilight ends will be as dark as it ever gets, limited only by natural air glow and in populated areas by artificial light pollution. Under truly dark skies, the number of visible Perseids tonight could approach the maximum theoretical rate of roughly 100 per hour during the peak window. Under suburban skies with some light pollution, the number will be lower, but the brightest meteors, the fireballs, will still be clearly visible. Under city skies, only the most spectacular events will punch through the background light. But somewhere within driving distance of nearly every city on Earth, there's a dark enough location to experience this properly. And tonight, that drive is worth making. The planetary alignment before sunrise adds a third observational dimension to the day that is accessible to anyone who can set an alarm and has a clear eastern horizon. Across much of the world, you can start the day with the planetary alignment before sunrise and end it by watching for some Perseid meteors after dark. The structure of the day itself becomes a kind of astronomical itinerary. Pre-dawn planets, daytime eclipse, post-sunset meteors, morning to evening, sunrise to far past midnight. The sky offers something substantive at every stage of the rotation. This is genuinely unprecedented in the memory of any living person in terms of the density of major events in a single calendar day. It is also worth being specific about what will not happen today, because clarity about the limits of the science is as important as enthusiasm about what is genuinely extraordinary. The planets will not align in a perfect straight line. Planetary alignments never produce precise geometric lines because the planets orbit at different inclinations to the ecliptic, meaning they sit at slightly different distances above and below the ecliptic plane at any given time. What will appear in the pre-dawn sky is a diagonal arc of planets strung along the ecliptic in a visually recognizable pattern, not a ruler straight line. The visual impression is still striking, the astronomical and geometric significance is real, but the idea of planets lining up perfectly like beads on a string is an idealization rather than a description of what the sky actually shows. The total solar eclipse will not be visible from most of the world. The path of totality is narrow. Outside that path, observers see only a partial eclipse, which, while interesting, lacks the dramatic quality of totality. Much of the Americas, most of Africa, South Asia, East Asia, and the Pacific will not see the eclipse at all. The Perseid shower is visible from anywhere in the northern hemisphere with clear skies after midnight, and is partially visible from equatorial and southern latitudes, though the radiant in Perseus never rises very high from far southern locations, reducing the effective hourly rate. And crucially, nothing about this triple convergence has any physical effect on Earth beyond the brief shadow of the eclipse and the light show of the meteors. Planetary alignments do not cause earthquakes. They do not cause floods. The combined gravitational pull of even 6 planets all on one side of the sun is utterly negligible compared to the moon's daily tidal influence on Earth. The claims that appear on social media around every major astronomical event, suggesting that planetary alignments cause seismic activity or that eclipses trigger natural disasters, have been tested and found to have no statistical support in the global earthquake and volcanic record. The events that have occurred this week, the Columbia earthquake, the Japanese earthquake, the volcanic activity at Campi Flegrei in Perseids, are the product of tectonic stresses that have been accumulating for decades and have no physical relationship to the orbital geometry of August 12, 2026. What August 12, 2026 does offer, without any mystical augmentation, is something that the honest scientific framing makes more rather than less remarkable. 3 major astronomical events, each meaningful in its own right, each with deep roots in human observation history, each visible from somewhere on Earth, converging on a single day. The shadow of the moon racing at 3,400 kilometers per hour across Greenland, Iceland, Spain, and Portugal. The debris trail of a comet whose last inner solar system passage was in 1992, burning in Earth's atmosphere at 60 kilometers per second, as particles that have been orbiting the sun for thousands of years terminate their journey in a streak of light at 100 kilometers altitude. 6 planets simultaneously above the horizon in the pre-dawn sky, each one a world in its own right, each one carrying its own history of telescopic discovery and scientific investigation. Every human being who steps outside tonight finds a dark spot away from streetlights, lies on their back, and looks up at the northeastern sky as seeing something that has been building toward this moment since Comet Swift-Tuttle last shed those particles into its debris stream. They are looking at the edge of space. They are watching physics happen in the upper atmosphere at speeds that no human technology has ever reliably sustained. They are sharing that experience with every other person on the night side of Earth who made the same choice. No one alive saw 1999's European eclipse from the Iberian Peninsula. No one alive has seen tonight's combination of events before. The sky is not commonly this generous with its spectacles, and it is not asking anything in return except that you go outside, find darkness, look up, and pay attention. The planets are there before dawn. The shadow arrives during the day. The meteors come after dark. August 12th, 2026 starts at midnight and runs until the next midnight, and there is something genuinely worth seeing at every stage of it. Go outside, look up. The sky is putting on the best show of the century so far, and it will not repeat this particular combination in your lifetime.